Soft drinks, they are everywhere and many people enjoy them daily. It is interesting to note that the perception on soft drinks have evolved significantly over the years. For example, in the early 20th century, soft drinks were seen as a refreshing treat, often marketed as health tonics. By the mid-20th century, their popularity soared, particularly among young consumers, with aggressive marketing, promoting them as fun, social beverages. However, from the late 20th century onwards, growing concerns about their high sugar content, artificial additives, and their connections to obesity, diabetes, and other health issues created a public perception of seeing them as unhealthy drinks. So, soft drinks, are they really bad as they portrayed in some instances? For example, if you look on the internet, you could see videos where people are conducting coke and meat experiment. This is based on a viral myth suggesting that soft drinks, especially cola, are so acidic that they can dissolve meat or rust within hours. I would say this is not true, and in a few cases the results are exaggerated. However, they raise concern about the strength of acids and other components in soft drinks. Today in this video, let us have a look at the components of soft drinks from a scientific angle and the potential dangers they pose to our health. Module 1. General composition of soft drinks. Okay, let us dive straight into the contents and chemistry of soft drinks. A typical soft drink contains main components as shown in the screen, each serving its own specific purposes. The main component of soft drink, of course, is water, serving as the base of the drink. The percentage range comes between 85 to 95% weight by volume, which indirectly means that around 15 to 5% of the soft drinks are other ingredients. Among the other ingredients, sugars or in general sweeteners comes the highest. Data shows that it comes around 7 to 12% by weight by volume in regular soft drinks. It can be little less or more depending on the type of soft drinks. For regular soft drinks, usually sugar or high fructose corn syrup are used, making soft drinks predominantly a highly sugary drink. For example, a 330 milliliter of regular Coke contains 35 grams of sugar. If you consider 4.2 grams of sugar as 1 spoon, basically it contains more than 8 spoons of sugar. In the case of diet drinks, artificial sweeteners such as sucralose and aspartame are used. The quantities of these compounds used in the diet soft drinks are much smaller compared to the normal sugars because they are extremely sweet compounds. However, these are synthetic compounds and it has its own drawbacks, which I will explain a little later. Some of the other components in soft drinks include acids, which are present in 0.05 to 0.3%. For example, acids such as phosphoric acid give the drinks its tangy taste and also act as preservatives. Most carbonated soft drinks have a pH around 2.5 to 3.5 and are highly acidic. Another component in soft drinks is carbon dioxide. When I mention about the acids, we have to consider carbon dioxide also in this category. The reason for that is carbon dioxide dissolved in water under pressure will become carbonic acid. The dissolved carbon dioxide comes up to 0.5% in weight by volume. As you know, the dissolved carbon dioxide adds the fizz and bubbly texture, enhancing the sensory experience. Other components in soft drinks include additives and preservatives, which comes around 0.1 to 0.5%. These include artificial colors, flavors, preservatives, and stimulants such as caffeine in some drinks. Now let us have a look at some of these individual components in detail. We will try to understand the chemical composition and its role in the soft drinks. Let us start with the most prominent ingredients of soft drinks, sugar. Regular soft drinks often contain high levels of sucrose or high fructose corn syrup. These sugars are quickly absorbed into our bloodstream, leading to a rapid spike in blood glucose levels. While we all know sugar isn't great for our health, it is important to break down what exactly happens on a molecular level. Sucrose or table sugar is metabolized in the body into glucose and fructose. Fructose, unlike glucose, is metabolized in the liver, where it can contribute to fatty liver disease and increase in triglyceride levels. Over time, excessive sugar intake can lead to insulin resistance, type 2 diabetes, obesity, and even cardiovascular diseases. So, what about the diet drinks? Are they any good? They use artificial sweeteners like aspartame, sucralose, and saccharin. While they might have fewer calories, these sweeteners come with their own set of concerns. Aspartame, for example, has been the subject of numerous studies. Some research suggests that it might be linked to headaches, dizziness, and even an increased risk of neurological disorders. Aspartame breaks down into methanol, which converts into formaldehyde in the body, leading to potential neurological effects like headaches, dizziness, and mood changes. Though regulatory agencies deem it safe in moderate amounts, the long-term effects are still a topic of ongoing research. Other two common artificial sweeteners used in the soft drinks are sucralose and saccharin. Sucralose is a modified sugar molecule where 3 hydroxyl groups of sucrose are replaced with chlorine atoms. Some of the harmful effects people attribute to sucralose are gut health and metabolic disruption. Studies show that it may reduce the number of beneficial bacteria in the intestine, which can affect digestion. Some studies also suggest that sucralose might interfere with insulin sensitivity and glucose regulation, increasing the risk of developing type 2 diabetes over time. Also, when heated, such as in baking, sucralose can break down to harmful compounds, including potentially carcinogenic fluorocompounds, since it contains chlorine. Overall research studies on sucralose have turned up with conflicting results, where some results indicated that it has little to no effect on blood sugar or insulin levels and gut health. On the other hand, some studies have indicated that sucralose could affect the gut microbiome and increased blood sugar and insulin levels. Saccharin is one of the oldest artificial sweeteners found in some diet sodas and sugar-free drinks. Early studies in the 1970s suggested that a link between saccharin and bladder cancer in rats, leading to concerns about its safety in humans. Though subsequent research found no strong evidence of cancer risk in humans, saccharin remains controversial and some prefer to avoid it due to its past association with carcinogenicity.